Okay, hello, I'm Dan Gibson, and welcome to another video where I'm interviewing someone. Today I have with me Marek Radzikowski. I've said his name wrong. He's corrected me a couple times. How do you say your name correctly?
It's Marek Radzikowski.
Okay.
And so there's two slight sounds that are different, just the D that are a J sound, Raj, and the other sound is off. O-W. It's pronounced not ow, but off.
Oh, okay. Well, that's a difficult one for me to get a handle on. Okay, just introduce yourself a little bit. Where are you from? And tell us a little bit maybe about your educational background.
Okay, well, I was born in Vancouver, Canada, and I grew up in that area and went to school at University of British Columbia and studied engineering physics there. And so I got a bachelor's in that, and then I went to Princeton University and studied mathematical physics there, and I got a PhD in applied and computational mathematics, with the subject being mathematical physics.
Okay, so you would describe yourself as a mathematician?
Yeah, mathematical physicist is kind of supposed to be both, so I've had to prove things in, to prove mathematical theorems concerned with physics.
Okay.
But yeah, in general, I'm interested in both topics as well. I'm trying to develop theories of physics as well.
Okay, now this video series is all about Islam. So how did you get introduced to Islam, and do you have any experience with Muslim people?
Yes, I first was interested in it through some friends in graduate school who, encouraged me to learn more about it through going to it was a kind of a Christian summer school on Islam, so I learned about it there, read a little bit about it from various books, and then over the years visited countries. For example, I visited Turkey in the 90s and met Muslim friends, made friends with some Muslims, and interacted with them somewhat on various occasions. And sort of, learned a little bit more about Islam through them as well.
Right. And did you have experience in the Muslim world, other than that?
Other than that, yeah. Most recently, I taught at the American University in Afghanistan.
Okay.
That's in Kabul, and so that was for 5 years. And there with, I was mostly there just teaching physics and mathematics courses, and also had some various conversations with people, sometimes about spiritual things or political things like that. Philosophy even. So I had various interesting conversations with them.
So tell me, as a scientist, how did you get interested in this whole thing about the Petra hypothesis?
Okay, well, I came back. By the way, I forgot to mention that there was an attack at the university that I was at, and that's one kind of major reason why I'm back here in Canada for the time being. And so since I've been back in Canada, I wanted to study more about Islam, just to understand it better, right?
Okay.
Because of some of those kinds of events which happened in Afghanistan, what I've seen there, and so I was interested in studying it from kind of from the Christian perspective, to see how we as Christians can best relate to Muslims, ordinary Muslims that we see, and that we can meet along the way. And so when I got back here, I interacted with people, and some of my Christian friends knew about your work and directed me to your work.
Okay, and you've had a chance to look at some of the data, and you told me you were interested in trying some different things with the data to see what the data might be able to tell you. What are some of the methods that you might be able to use, or you did use, in looking at the Qibla data?
Okay, well, so far I found that sometimes okay, when you look at the data, you have the number of mosques, and they face certain directions, right? So you gave data which told people what the direction is and what the directions of the other possible places actually are. For example, for each mosque, you show the direction of Mecca, and then you also show the direction of Petra and Jerusalem, and possibly other places, right? And plus the true direction that mosque was facing, up to your error, up to whatever error bar you had in your measurement.
Right. This is the first over a 200-year period, the first 200 years of Islam. Yeah.
So you did the first, yeah. So and then, so what I was interested in was looking at the average deviation, right, away from the center, or away from the average value. I'm sorry, from the average deviation away from, let's say, a sort of a target, a possible place of by so many degrees, right? But I was interested in, well, maybe those errors might cancel if you take the average, which is the correct way of doing it in statistics. So you look at the deviation, you have to detect you have to say whether it's positive or negative deviation, right, to the right or to the left of the actual the value, and then you take an average with those plus and minus values. So I did that, and I found that the error bar, the standard deviation from that, is even smaller than what you quoted. So when you do it the correct way, statistically speaking, you seem to get a more accurate result overall. So that it was concerning me that some people were saying that this was just was happenstance or a random thing, that this could be, it's just an insignificant result because if you take a lot of measurements and you have a lot of error, then they could end up pointing that way. So I was concerned about that because you have a simple, easy to understand argument, which I can give you, which shows that it's not that insignificant at all, right? So
sure. If you want to demonstrate something, go right ahead.
Okay, yeah. So I have a blackboard here, so I'll show you. So if one has 10 mosques, say 10 targets, let's call them, let's draw a dot, let's say. Well, the mosques could be anywhere, but I will represent them outside, let's say, the circle. So 1, 2, 3, 4, 5, 6, 7. Maybe I have 8 here. Well, so let's say you have 10 mosques, and you have 10 directions, say, inside the circle, 10 possible places they could point to. Okay, so the number of ways, if any of the mosques could be pointing to any of the 10 qibla, well, or the 10 how do you call them, targets, I would say.
Or different explanations of how the mosque might be oriented, yeah.
Yeah, so say 10 different cities. Let's say these are cities. Call them cities. So let's represent the color as green. So you can have this mosque pointing to that direction, or to that direction, or to that direction, etc. Right? And I won't draw all the arrows because you can see each mosque has 10 possible directions. Right?
Right.
And likewise, this mosque has, I'm just drawing 3 or 4 of them for each mosque, but it has also 10 possible directions, and so on down all the way around, right?
Right.
So if each mosque is pointing randomly to one of these cities, or each mosque is facing randomly one of these cities, then you can see the number of possibilities is 10 times 10 times 10 these are all the number of configurations that you can get. You
Right.
choose one of these directions, one of these directions, one of these.
Okay.
So the number of, can you see that? The number of possibilities, or the number of configurations, is 10 to the power 10, which is 10 billion.
Oh, okay.
Okay, and
So just with 10 mosques and 10 different options give us 10 billion different combinations. Okay.
exactly right. And now, if what your data is showing is correct, and they're all pointing in one direction, that is, they're all pointing in one city, then you have 10 possibilities for a configuration, all of whose directions point to one point.
Okay.
So I'd have to erase a bunch of these and show how that would work. So you would have all these gone, and one configuration pointing to just one of the points would look something like this. So all of the mosques would be facing in one direction like that.
Right.
And there are only 10 possibilities for a configuration like that, right?
Right.
Just at all the 10 points. So the total probability of that happening would be 10 divided by, so this would be the probability of all facing one city, is 10 over 10 to the power of 10, which is 1 in 10 to the 9, which is 1 in a billion.
Okay. Now, I'm not sure, because I can't see the screen, I'm not sure if people watching this video can see the full screen or not. Hopefully they can.
Yeah,
but
I could try to point it a little bit.
They're just, a little better. Okay. So
Yeah, okay, you could always try doing this again. I could improve my lighting and things like that.
that's okay. What exactly does this mean? Okay, you're saying if it's all by chance.
Yeah, so if this is by chance, okay, so to give you an idea of how small this number is, a billion, how many seconds is a billion seconds? Well, if you do the calculation, it's about 30 years. It's over 30 years.
Right.
So if you were able to choose a configuration every second for the next 30 years, then only one time in that 30 years will you get a configuration where they're all pointing in the same direction.
Okay.
They're all pointing in the same city. They're all pointing
Right.
to the city. Okay. So that's the magnitude or the difficulty of actually doing this by random chance. So I mean, with that in mind, it would be a very serious mistake, I think, to say that this was by chance, right? Because if you do an actual calculation, a probability calculation, you get a result like this. Now, with your data, you have even more cities that you're talking about, and this kind of argument can be, it should be made in a more rigorous way. But the way I see it, it would just lead to even smaller probabilities, right? It could well lead to even smaller probabilities. So, it's at least motivated me to think about this problem some more, right? So,
right. Well, at this point, there's only two major theories, and one is that these mosques are oriented and to things from the stars were set this way, or the Kaaba building was set, or so forth. And the other one is myself, who have looked at this data, and with over 50 mosques that we can identify very clearly, over 20 of them point directly at Petra, over 20 of them point directly at the between position, and so forth. So you're saying the chance that is just by chance is very small, that they would they would just by chance, because if they were intended to point somewhere else, it would be very unlikely that they would all point to these specific places.
Right. Yeah. If they were randomly, if you were randomly choosing directions, then you would get, you would get way more possibilities. So the actual the pattern that you're finding is very, very rare. The pattern that they're all pointing towards the same place is very, very unlikely, unless there's some design to it, unless there's some, it was actually purposely done. Right? So not only does it tell me that this was purposely done, but it also tells me that whoever did it had some good technology in getting their measurements correct.
Yeah, and that's the one where everybody's working on now to decide what was the technology and how could they do it, and that's something that for a topic for another series of videos. Yeah.
So, if you, for example, if you change the numbers and you have 20, 20 mosques around in 20 cities to which they possibly could be pointing, then you would change the numbers, by changing the 10 to it and the 10 here. So it becomes, I can just correct it quickly.
Everything doubles.
Well, it's not just double, but this is now, this is not even 20 billion. This is way, way more than 20 billion already, right? This is 20 to the power 20.
Right.
So it's so 20 billion. Anyway, it's just an extremely small number. So you can see it'll be something like this: 20, 1 to the 20 to the 19, which is incredibly.
I'm looking down at a screen below the camera, so no, that's okay. I can see it fine.
Right.
The one that really got me, because some people will argue, well, the mosques in the north needed to point south, the mosques in the south needed to point north, so that will reduce the actual number of possibilities. But what got me was like mosques like the Yamama Mosque, which is between Petra and Mecca, and it points north to the between position when it's against all other odds, because it should have been pointing down to Mecca, and it actually points away from Mecca and up to one of the others. So as you said, this indicates there is some sort of design to this. It wasn't just some sort of random thing, and if they're just random, and then it just happened to be that more than 20 point to the between position and more than 20 point to Petra. And then if we add time in, it just happens to be that during, a 40-year period of time, that all of these mosques, the between ones, just happen to point to the between just during this 40-year time, and then it stops. Something greater is going on than just chance or just different abstract things that people were picking up on. That's the way I interpret it, and I'm looking at this, and that's how I'm seeing this. Is the probability of this happening by chance is just astronomically, not probable that it would happen.
Right. Yeah. It looks like that, and I'm still doing further research. I mean, we still need to check things out, of course, and so I'm looking at other statistical methods, not just. What I've done so far is basically taken an average of the deviation from Petra, and then found the standard deviation to be, for example, in the first 100 years of those mosques, it's less than 1 degree.
Right.
It improves your error bar. So that's the standard deviation. So what that means is the standard deviation. If I could draw another picture.
Sure.
It refers to a Gaussian distribution, or a normal distribution. So it's a typical distribution that you would use for a situation where you have many measurements, right? And in statistics, anything over 10 measurements over 10 is pretty close to meaning. So a Gaussian distribution looks like this. So it's very close to zero as you stray far from the mean, and the center of this distribution, it's symmetric, right? And the center of this distribution is called the mean, mu. Mean is spelled M-E-A-N. And the width, which is kind of a half width at a certain height of this peak, is called sigma. So this is the standard deviation. Okay. All right. So one standard deviation away from the mean encompasses. Okay. So the total area under this curve is 1. So that means the total probability of finding a measurement anywhere along this axis, which is, let's say, the variable is x. So this is a probability density of x. So it's you have to take the height, basically. Take slices, vertical slices like this, and then take the height times the width, right? The width times the height, and then multiply. You get an area, and then you add these areas up. It's called doing an integral, so we get into calculus here. But anyway, the total area when you do that under the curve between mu minus sigma and mu plus sigma is about 68%. So that's this area here. So what that's saying is that the probability of going away from mu, the mean, by more than sigma on either direction, on either side, is less than 32% or something, right? And if you take 2 standard deviations away, then it goes down to about 95%. And if you go 3 standard deviations, it's about 99, I think, percent. Anyway,
Okay.
I should give you correct numbers. Okay, sorry if I don't perfectly right here. But it goes more and more rapidly, extremely rapidly to 0 as you go away from, as you take a greater number of standard deviations away from the mean. It goes exponentially fast, 0. Okay, so let's see. So so what I did was you can by taking data you can find the mean by taking the average. So you estimate the mean by taking the average deviation. Okay. So I did that. There's a formula for the average. You just take the number of values, you sum them up. Okay, I'll use summation here over all the values to n, and then you divide by the total number n. So that's going to be an estimate for mu, which I call mu hat. Okay, so mu hat is going to be close to mu if this really is a standard deviation, and one should test that later, right? One should test those things later. But the other thing is you want to find a sample standard deviation, and that's done by taking squares of the differences of each value with the mean, with the estimated mean, and then taking the average values and dividing by n minus 1. Okay, so and then you take the square root of that. So this is actually, you have to take the square root of that. Okay, so when you do that, you get a good estimate for the standard deviation here, and here you get a good estimate for this mu. And the more data points you take, the smaller the closer this estimate will be to the actual one. So what I did when I looked at the mosques in the first 100 years, I didn't write it down. I think I wrote it down in a PDF file, which I could bring up. But I think the mu was something like plus or minus less than 1 degree just a little, just a bit, just less than 1 degree. I forget what it was. The absolute value of it was less than 1 degree, and the sigma was also less than 1 degree. Right, for the mosques that I looked at. Okay, so the errors were canceling themselves out. There were deviations to the right or to the left of Petra, and so this would show a high degree of accuracy, right? But the more data points you take, the better. You might still get an error bar this small, right? But it's more established when you have a greater number of points. Okay, I'm assuming n is over 10 here.
Okay. Now, I am not a mathematician. That's why I rely on people like you to help me with this. So sum up, what are you saying here? When you took the different degrees and you put it there, you said some are this far out on the right, some are this far out on the left, therefore they sort of cancel themselves, and it looks like they are actually focused on, like if you're doing the Petra mosques, that they are actually focused on Petra. Is that what you're saying?
Yes. Okay. So let's say that I'm at a certain mosque and I'm facing the direction. It's Petra, and I want to find the correct way of building the mosque.
Right.
So the designers of the mosque need to know how to find the direction, and then they build the mosque accordingly. They have the wall perpendicular to that direction, and they build the rest of the building according to that direction, right? So if they make an error, then it might be a little bit on this side for one mosque, but maybe in the next mosque they might use similar techniques. They might have the error on the other side a little bit.
Okay.
As you go all around, the error might be, this way or that way, right?
Right.
Now,
depending on their technique, they might not be able to do it exactly right, but they could be out by a few degrees. So yeah, you're going to get a splatter pattern.
Right. Yeah. So sometimes the error is on this side, and sometimes the error is on this side. You expect that 50% of the time the error will be on one side, the other 50% will be on the other side.
Okay.
On average, like do this in a large number of times, and so taking the average has the benefit of canceling those errors out, right? So that's why I was saying I was including the sign of the error, not just the magnitude of the error bar.
Okay.
As you did, right? I mean, you displayed all your data, which showed whether it was a positive deviation or a negative deviation. I took that into account, right? So when you take this average, those errors will cancel out, and you get a better estimate for the mean.
Right.
Yeah. Which in this case would be close to 0. So that was indeed consistent with this number. Okay. So I would have to bring up my PDF page.
Yeah. No. So what your conclusion is that everything was within a degree.
Yeah. Very close to a degree for the mosques in the first 100 years.
Wow. Can I ask you another question? Are you finished with this? Can I ask you another question?
Sure, you can ask another question. Yeah.
Okay. You mentioned, this was when I first talked with you, which was probably a couple years ago, when you first approached me, and I asked, can you test data to see if it's been tampered with or if it's actually real data? I mean, like what you would expect, because that's what I've heard can be done with data, and that's how you find fraud and so forth. Can you do that with this kind of material? Is this one of those tests?
This by itself is not one of those tests. This would be a sort of a preliminary. So the first thing that you would do with data of this sort, you would find an average, find the mean, you'd find a sample standard deviation, and then you would test that out by you would try to do a best fit analysis. So you can do what's called a chi-squared test for best fit. So I haven't done that yet, but you would simply see if the data follows the normal, follows a random or a normal distribution, for example. So everything that I've assumed here, well, the biggest thing I've assumed here is a bell curve or a Gaussian or normal distribution. I would test that out.
Excuse me, Dr. Radikowski. Can you move your camera back to the left a little bit, because we can't see you even a little more? Yeah, that's probably center. Yeah, if you're in the center, then we can actually see you. Okay, sorry to interrupt you. Continue on with what are some of these tests?
Yeah, so a chi-squared best fit test would be appropriate in this case. So that could be done. So if the data is too nice, then the chi-squared best fit test can detect that. For example, too nice would mean that the deviations from the expected value are too small. It looks like you're throwing out some values, and you're just putting in the best values, the values that support your hypothesis, rather than looking at all the values that you got. Right. So doing such a thing. So apparently Mendel did that with his genetics experiments. He threw out the data which didn't support his hypothesis. Even though his hypothesis turned out to be true, it wasn't good science because he was throwing out data that didn't fit his model. He was cherry picking.
Right.
So you're not, as far as I can tell, I don't see that happening here.
Yeah. Did you run any of those tests, or you looked at the data? Okay. I'm just curious because I know you were interested in that at that point, and I'm very much like the data to be checked to see if somebody is just imagining something and seeing it and ignoring something. Those are all good things to do, because a lot of people, this is a very important topic because it has to do with their faith and things that they've put their trust in over the years.
Right, yes. So anyway, to give another possible way of seeing what the statistics can tell you, just from this calculation alone, if you there's a further branch of statistics. Roughly, statistics is when you take a course in statistics or you have a course textbook, it's roughly divided. The first half is roughly probability calculations, probability distribution.
Okay.
Sort of how you measure, how you can, take polls accurately, and what kind of polls you can take, things like that. How you can quantify your data, and also how you things like this, finding the mean, how you can characterize your data by finding the mean, and also by finding its variance. That's going to come up here as a standard deviation. And the second half is usually on inferential statistics. So in inferential statistics, you have usually a null hypothesis, and you want to test that null hypothesis. All right. So the null hypothesis here in this case would be that the mosque originally, say, pointed to Jerusalem. Let's say that's a common one. That's a commonly heard one. And Jerusalem might be, somewhere. In our case, in the first 100 years, depending on where the mosque is located, say Jerusalem might be here. If the mosque is situated in another part of the world, Jerusalem might be over here.
Okay.
And if one is directly in line with, so that if you're directly in line with both Petra and Jerusalem, right, then Jerusalem will be right here.
Right.
So the whether or not the data confirms or supports the null hypothesis is a little bit problematic because you have different places where Jerusalem is. For the mosques which are sort of pointing far enough away from Jerusalem, you can see that, well, the null hypothesis is definitely not supported there because it's just too far away. The probability of going that many standard deviations away from the center is just too big, right? And so you'd be forced to reject the null hypothesis there. So, but because you could be in line with with Jerusalem, that suggests, well, you have to do a little bit more rigorous analysis. So I've been thinking about how to do that. It seems like a newer kind of problem, at least for me. So I'm not a statistician. I didn't study that except as an undergraduate, as an engineering physics student. But I did teach a first course in statistics at American University. So I didn't, there are others who are much more specialized who would know better the terminology of that, right?
Right. Well, maybe in another interview we'll have a statistician on here who can work maybe together with you or others, and we can try to figure out what some of those probabilities are. Because I really would like to see what mathematics can tell us about these different Qibla theories, and what is more likely than others, and to make sure that we are actually correctly using the data that we have and not manipulating it, even unconsciously, because we'd like to see it reach one result rather than another one. Okay.
I lost you for a second there.
Oh, okay. I just said I'm very interested in math because I don't want us to even unconsciously maybe manipulate some data one way or another. We need to be truthful to the data to see what is it actually telling us and showing us.
Right.
So, is there anything else you'd like to share with us before we close off?
I think that's all for now. I think I'm still thinking about it, and I'm happy to talk, especially with other mathematicians, about this problem, and to look more at the Qibla data in your book, right? In your early Islamic Qibla book. And to look at the other data that you might have that's more recent as well.
Right. The latest is on the website, The Sacred City. And I'll put that address on the bottom of the screen so that everyone can see it. You can go there and see the Qibla tool, and that has the latest data that we're trying to gather everything into one place and keep that one current, because we're finding new mosques and measuring. So we would like to have all of the data all in one place. So it'll be there.
Okay.
Good. Thank you for being with us. Appreciate you having here.
Okay. Have a nice day.
Yeah, you too. Thanks. Bye-bye.
Take care. Bye.